Okay, so continue with our journey. So we go to number 5 now. Okay, so number 5. So number 5 is integrate x to the power 3 over x to the power 4 plus 9. Okay, so this is dx. Okay, so this one also you can check, you can see that x on top here has a power 3, then at the bottom or the numerator has a power 3. So you compare the powers of x, so they are similar. You see, this is x, this is x to the power 3, this is x to the power 4, so this is 4. You subtract to give you 1, so meaning substitution method. Substitution method is the easiest here. So substitution method is the one to employ. So you have x power 3 over x. So here there is a slight change. Here we are not just getting x. So if we substitute, for example, let u equals to this, we are getting everything. Okay, so we are getting everything. Yeah. So let's continue. So here the highest power of x is at in the denominator. See, it's in the what denominator, which is so we can say u equal to x to the power 4 plus 9. So u is equals to the variable with the highest power. So if this was on top, we could have gotten it. Still, if it was at the bottom, we just get it the way it is. So you get it together with a 9. You don't just get a 4 here, x to the power 4. So that's a difference with the area one. The area one we are straightforward, but this one is slightly different because x is combined with some variable here, or a constant 9. So next we find du dx. So du dx, we are differentiating. So rewrite. If you are differentiating here, you say n x n minus 1. So we say 4 x. Okay, so this is 4 minus 1. Then plus a derivative. Differentiating any constant is 0. So you are differentiating derivative of a constant c is 0. So it will be 0 here. 9, if you differentiate 9, it will be 0. So du dx is equals to 4x, 4 minus 1 will be 3. Okay, so next what do? You make dx subject of the formula. So same things, over 1 cross multiply du equal to 4x to the power 3 dx. So making subject of the formula dx, so we divide by 4x to the power 3 over 4x to the power 3. Okay, so you have dx is equals to du over 4x to the power 3. So now we substitute where there is dx, we put du over 4x. So now we go back to our original equation. Our original equation is x to the power 3 over x to the power 4 plus 9 dx. Okay, so this now is written, you have x to the power 3 over, so this we've set this equals to u, so this will be u. then multiplied by dx is du over 4x to the power 3. So 3x and 3x will cancel out, so x to the power 3 I mean cancel out, so we'll have so 1 over 4, we'll take it outside, 1 over 4 integral 1 over u du. Okay, so if you remember, 1 over linear function is that linear function, so 1 over u, integral of 1 over u is ln u, so 1 over 4 to be ln u plus c. So this is same as 1 over 4 natural log. So u now will replace u. U is what? X to the power 4 plus 9 plus c. Okay, so we write here integral x to the power 3 over x to the power 4 plus 9 dx is equals to 1 over 4 ln x to the power 4 plus 9 plus c. Okay, so this is your answer. Okay, so let's continue solving. So let's go to question 8. Okay, so question 8. So question 8. Okay, so let's continue. Grab this what? Okay, so we have part 8 now. Okay. So part 8 is integrate 1 plus cos x over x plus sine x. Okay, so this one dx. So for this one, I think the best way is using quotient rule, because here you don't seem to any method which can work best except the quotient. The quotient rule is the one where I say we have u over v is equals to u prime v minus v prime u over v squared. Okay, so v is a denominator, so we write v is what? V is x plus sine x. Okay, then if we say v prime is differentiating, so x differentiating x is just 1, because remember x to the power n is equals to n x n minus 1, so it's just x to the power 1, which is 1 x 1 minus 1, which is 1 minus 1 is 0, x to the power 0 is 1, so 1 multiplied by 1, which is 1. Okay, so this is x plus differentiating sine to be cos x. Okay, next let's go to u. U is a numerator. What is on the numerator? 1 plus sine cos x. 1 plus cos x. Okay, 1 plus cos x. So u prime, which is the differential of this, is it 1? Okay, let me see again. Okay, 1. Okay, so differentiating a constant, I'm repeating again, so we have repeated many many times. So a constant, it means a number. A number, it can be 10, it can be 100, it can be 200. This is 0, so this will be 0 plus differentiating cos, it will be negative sine x. Okay, so u prime equals to negative sine x. So now we apply this formula, substitute what u prime is, v prime u, v prime. Okay, so this will be equal to, so what is u prime? Negative sine x. Then v, what is v? V is x plus sine x. So v is x plus sine x minus, so now we have u, 1 plus cos x, and then v prime, what is v prime? 1 plus cos x over v prime. V prime is what? So v is what? X plus sine x squared. So let's see if we can simplify this further. Okay, so those two, so on top, if we multiply throughout by sign, so we have negative, if we start with, x, so this by this will be x, negative x sine x minus sine by sine, sine squared x minus, so here we multiply out these two, so we have 1 multiplied by 1 plus cos x and plus cos x multiplied by 1 plus cos x. So we're expanding, then you have x plus sine, oops, sorry, okay, so okay, so sorry about that. Okay. Okay, so continue. So this is x squared. Okay, and then write it nicely. So this is negative sine x. Okay, so there is x here, minus sine squared x minus, so in the bracket it is 1 plus cos x plus cos x plus cos squared x okay. Okay, so over okay, so we have everything over x plus sine x squared. So I was trying to manipulate so that we can get a negative. Okay, so let's see negative x 1 plus this was this 2 cos x plus cos squared x x plus sine x power 2. Okay, so next let's distribute the negative. So negative x sine x minus sine squared x minus 1, okay, minus 2 cos x minus cos squared x over x plus sine x squared. Okay, so we can group this one and this one here. We remember the identity cos squared x plus sine squared x, so we want to utilize it, x and sine x. So minus 1, this one, minus 2 cos x. Then let's take out the negative. So when the negative is out, this will be sine squared x plus this also, the negative is here, so cos squared x, then x plus sine x squared. Okay, so in the brackets here it will be 1. Yeah, you just remember from our previous video, I derived this identity. So minus 1 minus cos, okay, there's 2 here, cos x minus, so here in the side bracket will be 1. Okay, I'm just trying to see if you can simplify it more further so that it looks neat. Okay, so we have negative 1, it will be negative 2, so this is same as negative x sine x minus 2 cos x minus 2, okay, over x plus sine x squared. Okay, so let's write it neatly. Negative x sine x, so we can take out the negative 2 outside. It looks at least okay like this. This we can leave it something like this. Okay, squared. Okay, so this is the most simplified form. Okay, so if you remember, we are solving question 8. Okay, so 8. So 8 was integrate. Can't even trace it. So we have 1 plus cos x over 1 min x. Oops, just erase it a bit. X plus cos x dx, which equals to into x sine x minus 2 cos x plus 1 x plus sine x plus c. Don't forget c. Okay, so this is the answer for part 8. Okay, so stop this video, then we'll continue in the next video. Thank you for watching.